Welcome to the new session. In today's lecture, we are going to continue with the same topic we discussed in the two previous lectures, that is sedimentary rocks. For a quick revision, that we have discussed about sedimentary rock, what is a sedimentary rock, how these rocks are forming, and we discussed the structure and texture of sedimentary rocks, and what are the importance of this structure and texture to identify the characteristics of a rock or the environment of deposition of that particular rock. So these are the topics we have already discussed. Today, what is my plan is to discuss basically about a few sedimentary rocks. Okay, so if I'm talking about a few sedimentary rocks, the important sedimentary rocks are on the screen. This we can call it as a breccia or a conglomerate. I'm mentioning only the important sedimentary rocks, breccia or a conglomerate. By the time you may be aware that what is a breccia or what is a conglomerate, and sandstone. Then there are shale, and there are a few non-clastic sedimentary rocks like limestone, dolomite, and coal. So this, if you have a general understanding of all these different four varieties of sedimentary rocks, I assume that you will have a general idea about the entire sedimentary rocks are in its variations, which is available on the surface. Okay, so what we're going to do is that we are going to discuss it one by one. Let us go to the first sedimentary rock, which is breccia. What is a breccia? Breccia is a sedimentary rock made up of what size of fragments? That is gravel size of fragments. And what is the size of gravel? That is more than 2 millimeter in size. So if you see the size of these fragments which are present in this rock, they are all more than 2 millimeter in size. Not all, there are mostly the more than 2 millimeter in size. So we call it as a gravel size particle. And another important factor is the shape of this. You remember the texture what you have studied. We studied about the sphericity and the roundness of the rock, and here we are talking about the shape of the rock, that the shape of the rock is angular in nature. Okay, so if the size of the fragments are more than 2 millimeter fragments, which is the major clast of the rock, and these clasts are bounded by this black color material, so this we call it as the cementing material. Okay, so the cementing material may be a cement, that is maybe a calcium carbonate which is precipitating within the rock, or maybe some silica, or maybe some iron oxides, or something, anything which will be acting as a binding material. That can be that we call it as a cementing material. So we call it as a cement or a matrix. Cement is the post depositional features. Post deposition to the grains, there are some precipitations or some chemical changes which will bind the sediments together. And the matrix is a term what we generally call, which are the fine grains or the materials which are going to deposit along with the grains, and that will act as a binding material. So in this case of the rock, what we see on the screen is a breccia, which are made up of more than 2 millimeter size of grains, and are of shape. Shape is the important thing which differentiate between the breccia and another rock type, that is the conglomerate. Okay, so if you see here also, in this case also the conglomerate, there are grains or the sediments are of more than 2 millimeter size, and they are bounded together by fine grain materials. We call it as a matrix or a cement. So this rock we call it as conglomerate only because both of them, if you see in some aspect which are same, the size of the main grains are same, the cementing material may be same, but the primary parameter which differentiate between these two kind of rocks are the shape of the grains. So in case of breccia, the grains are of angular in shape, whereas in the case of conglomerate, the grains are of, or the sediments are of rounded in nature. Okay, so when you say that this is the classification, there are so many stories which are associated with difference in the shape. Because when we say that the grains are of angular in nature, so that is an indication that the grain is not been rolled much, or it not been undergone much of the erosion or the transportation processes, and the sediments which are somewhere from the nearby area derived and deposited and then converted to a rock, and it produces a breccia. Whereas when you talk about the grains or the sediments which are rounded in nature, that means it has gone through a prolonged transportation process, probably by any agents like a wind or a river, or by any such agents which has been moved a prolonged duration, and it's converted to a rounded rock, rounded fragments. Okay, so this kind of information is what we get from the source of the rock, which based on its characteristics of the texture what we are talking about. This parameter what we are talking is the size, and the shape what we are talking about, we generally call it is the texture. So texture of a rock is an indication of the origin of that rock and the process of formation of that rock. Now, when you talk about these different rocks, then there are some kind of breccia which are associated with the faulting. You will study that what is faulting, or if you maybe having general idea when we discussed about the earthquakes. So we discussed that the rock breaks and it creates earthquakes. So that breaking of the rock, we call it as a faulting. The breaking of the rock, and it displaces. So that displacement, what it happens in the rock, we call it as a faulting. And that fault, when it happens, we are assuming in the textbook, when you see that, we'll see a straight line or a curved line which representing the fault. But in the actual ground, when we see a fault, it is a region where the rocks are crushing and grinding and breaking. Okay, it is not a very thin or very sharp cut that is something like made through a knife. It is going to be a breaking where large amount of rocks will be crushing into small parts. So that rocks are mostly going to be angular in nature, because they are not going to be transported much. So, okay, so the subaxial breccia is a another kind of rock which having same size and the shape, but it is due to the selective transportation, and the large crystals are deposited, large sediments are deposited or remains in the area because the finer sediments have been removed by some agents. So what left is the large fragments of fragments of sediments which are not being transported. Like that, there are a number of varieties of agglomerating breccia, angular and subangular gravel sediment derived from volcanic eruption. We call it as a agglomerate. So, during the process of volcanic eruption, also there are so much of things which come out during the explosion. So that explosive things are going to be mostly angular in nature. So that kind of things will be an indication of a volcanic eruption in the region. So like that, there are a number of different varieties of breccia. We'll get an idea which environment this has been formed if we study that. Similarly, if we talk about the conglomerate, there are different varieties of conglomerate that are based on the source of gravels. These are either a basal conglomerate that is forming the base part of the any deposits. And for example, if you see a surface and there is a tree, and there are a number of layers of sediments, and at the bottom of the layer we get the conglomerate. So that we call it as a basal conglomerate, which indicates the base bottom part of the deposition. Glacial conglomerate, which is derived by the glacial processes, and volcanic conglomerate, these volcanic rocks which erupts and the large particles of rock fragments which are depositing and then it transported and deposited. If it is having a rounded shape, we call it as a volcanic conglomerate, and if it is have an angular shape, we call it as a agglomeratic breccia. Okay, so based on the type also it classifies that is a oligomictic or a polymictic. Oligomictic will have a simple composition made up of quartz, chet and calcite, and the polymictic have a different varieties of sediments within it. It will have a number of different varieties. So it's a mixture of so many things. Okay, so this is what the first group of rocks, they are formed by the large particles of more than 2 millimeter. We classify it into two categories: breccia and conglomerate. So this term should be familiar to a civil engineer, because when you go for a foundation, so the report sometimes read that the bottom portion of the expected excavation for the foundation is having a rock type that is conglomerate or it is breccia. then you have to imagine that, okay, this is a sedimentary rock formed by and the process of short transportation in case of a breccia, or long transportation in case of a conglomerate. And if there is a conglomerate present, then you have to imagine that what are the conditions this conglomerate can form. It is either being transported by a wind, a river, or it is being as a process of removal of material and the basal conglomerate. Or so that actually will give you an idea about the geological characteristics of this region, because we are talking about the Earth, which formed around 5 billion years before, and all these rock types what you are getting are of sometimes it may be younger, like 1 million years or 2 million years, or sometimes it may be older, like hundreds or thousands of hundreds of million years before. So all these things is the history of our Earth. Only information for a civil engineer to get from is actually from these rock types. Okay, so a general understanding of this will help a civil engineer to read any of the geological reports, and they get a very good information that will obviously going to help you in the decisions. And if you are not able to take the information from this kind of rock types and the reports, then some mistakes or some loss you are going to face in the actual process of engineering construction. Okay, so now let us move to the second. Now the coarser, we know that it is breccia made up of gravel size. What is the next rock type, or the sediment size, which is having less than 2 millimeter and to 61 by 16th of a millimeter size? We call it as a, what is it? It is called sand. So the rocks which are made up of sand size particles, we call it as a sandstone. Okay, the size range we discussed yesterday, that in the texture, that is 2 millimeter to 1 by 16th of a millimeter. And this classification of the sandstone, and when we study the sandstones around the world, we have realized that the major composition of sandstone, when we see, they are predominantly of three different group of minerals. And what are those three different group of minerals? That three different group of minerals are, one is quartz, another is different varieties of feldspar, and third category is the lithic fragments. Lithic fragments means it is a fragment of rock. It is not a mineral, it is a rock. So based on that, the classification of sandstone is done. If you remember the igneous classification what you have discussed, based on the quartz, feldspar and feldspathoids, so that same way, there is a triangular plot. If you are not clear about the triangular plot and the areas, defining the area, then I suggest you go and watch the video we discussed about the igneous rocks, because I'm not going to repeat the same thing over here. So based on that, the groups have been classified, and along with this, there is one more parameter which taken, that is the percentage of matrix. Matrix we discussed yesterday. What is that matrix? Matrix is the material which is binding these grains. So if these materials are binded by more than 5% of more than 5% of matrix, then it goes into the next level of diagram. So this is the three-dimensional way which is measuring. So here also there are similar kind of classification, but what we do, we use the term, call it as a wax. Okay, where at to 5% we use the term that is a arenites. So when I use the term arenites, so that it indicates lithic arenites. What is a lithic arenite? Lithic arenites is having a more percentage of what? More percentage of lithic fragments, and it will have a minimum percentage of quartz. Oh, sorry, it will have a 90% to 0 to 90% of quartz. So that way it will vary. For example, if I make this line will have how much? Suppose 20% of feldspar, and this line will have how much? This line will have around let us see 70% of quartz, sorry, 70% of lithic fragments, and the third line will have 70 plus 20, so 90 plus 10% or 15% of sorry, that will have sorry, I made a mistake here while plotting that. So this line, the first line, what I'll remove this and explain again. Okay, so for example, if I take a mineral which will have around 50 percentage of what this is the feldspar. The feldspar is 100 percentage here, feldspar is 0 percentage here. So this line indicates feldspar is 50 percentage. Okay, so there is another line. This line indicates which is lithic fragment is 50 percentage. So there is no chance of the third because already which is 100 percentage and it is intersecting here. So this is the area where it comes in. So based on that way, based on such kind of triangular plots, we can identify the characteristics of the rock. So which field it comes in, based on that we'll call the rock into the particular name. If it is having more than around more than 90 percentage of quartz and less than that or 10 percentage is feldspars and the lithic fragments, we call it as the quartz arenites. And other rock types which is having feldspathic arenites and the lithic arenites, that will have less than 90 percentage of quartz. The percentage of quartz will reduce and the percentage of lithic particles and the feldspathic particles will increase. And if this are having more than 5 percentage of matrix, then that will go into another diagram which is in three-dimensional way, which is plotted here. And instead of this lithic arenite, we will call it as a lithic wax and the feldspathic wax and the quartz wax. Okay, so something like that, the changes on the name will come. So these are the sandstones. So sandstones are again classified into different characteristics based on the material which cementing together. So these are called siliceous. Those, why I am mentioning all these terms is to give you an idea. So these are the different type of terminologies we are going to expect in a geological report. So for example, siliceous sandstone. What does it mean? The sandstone, that means the rock which is made up of sand-sized particles, and it is a sedimentary rock, and they are bounded together by silica. Right, silica. So that is what the meaning of this siliceous sandstone. So just by understanding the name of the rock, you get a lot of information like what is this rock. Calcareous sandstone. What does it mean? The rock which is made up of sand-sized particles. It is a sedimentary rock and they are bounded together by calcium carbonate. So carbonates are the main. Argillaceous sandstone, the sandstone which are bounded, or the sand grains which are bounded together by argillaceous material, that is clay sized particles, or the fine clay. So ferruginous, there is the iron, that is iron oxides are the main cementing materials. So this is how we get to know from the name, or we assign the name of main name to your sandstone based on its material, based on its mineralogical composition, or based on its process of origin. So there are different ways. All these different terminologies will give you an idea of what kind of rock it is and how it has formed. Okay, so now the the next group of clastic, then this is in the group of clastic sediment rock, which is the shale. So conglomerate, sandstone, then the next group of rocks which are made up of fine grained sediments, we call it as a shale. So shale are the fine grained sediments having clay size sediments, very fine sediments. Clay, you know that this the material which is used for preparing the earth pots, matka banana ke liye use karte. So that kind of material we call it as a clay. So that clay combined together, it forms a shale. So there are different classifications also available about the or types we can say, that is residual shale, which is the remains of the shale, transported shale, hybrid shale, and based on mineralogy, it may be a quartz shale, feldspathic shale, chloritic shale, micaceous shale. So micaceous shale, which is having more amount of mica. Feldspathic shale will have feldspar in it. Quartz will have a quartz shale will have a quartz concentration in more in it. Chloritic shale will have more amount of chlorides in it. So basically this is a group of rocks, something like that. If you identify, if you see a rock which are of very fine and the grains are not being visible, and if it is not igneous or sedimentary or igneous or metamorphic origin, we can say that it is a shale rock, which is a sedimentary rock. Okay, so these are the three main categories of clastic sedimentary rocks. All these what is clastic sedimentary rock? Clastic sedimentary rocks are the rocks which are formed by the process of erosion, transportation, deposition, and the consolidation. So that processes where it is going through, then we call it as a clastic sedimentary rock. And there are three categories, which are conglomerate or breccia, sandstone, and shale. And within that, there are a number of different names or terminologies. But at least if you have a general idea, these are the three main categories that will give a lot of help in your future. Okay, now there are the second category, which we call it as non-clastic or the biological or chemical processes which originates the rock types. Okay, so this we call it as the limestones, composition of calcium or magnesium, carbonates of calcium and magnesium. So they are predominantly made up of calcite, dolomite, quartz, feldspar are common in this kind of structure. So there are a number of different varieties in that also. At this stage, you may not be able to identify that these all different varieties by its look, but the terminology is better to be familiar with. Chalk, shelly limestone is a limestone, calcium carbonate, we have shells, argillaceous limestone, lithographic limestone, Concur, calc sinter, biohermal limestones, biostromal limestones, pelagic limestones. So whenever you hear this kind of terminologies, so it is giving an idea, okay, this is a limestone made up of the calcium carbonate. So this is a chemical or biological process of origin. Okay, at least if you are able to understand that much is sufficient at this moment. Now next is a dolomite. Again, it is a carbonate. So this is having a chemical composition variation from the limestone. Limestone is basically CaCO3, and when it is having a magnesium more in it, so we call it as a limestones. Okay, so there are differences. Gravity would be slightly different in the conglomerate. So the effect of calcium, the acids. So limestone, the basic characteristic you must have studied it in the 12th science also. The calcium carbonate, the test for the calcium carbonate is to put a drop of acid on the calcium carbonate. So if the calcium carbonate is present there, it will create the brisk effervescence. So the bubbles it will come. So that is a test to check whether it is a calcite or not. So that reaction would be very high in the case of limestone, that is properly CaCO3, whereas that would be very less, effervescence will be very less in the case of a dolomite. So that is a check. The dolomite will be rough and mostly sandy, so the grainy feel you when you touch that, whereas in the case of limestone you will get a very smooth and clay appearance in the case. So these are the main two chemical sedimentary rocks which are important. Now the next is what we call it as a coal. You must be very familiar with the coal. Coal is sedimentary rocks of carbonaceous character and biochemical origin. So which are basically formed by the raw material, that it is the plants. So the plants which is on the surface that gets buried, that gets died and that gets buried in the layer, and these buried sediments will be the overlaid by the layer of other sediment. Then it compact and compact and compact. As and when it compacts more and more, so as and more it compacts, so these compactions will create a number of different varieties of coals. So the coal which is producing, we call it as the first form of the coal, we call it as a peat, then it is a lignite, then it's a bituminous coal, then it's an anthracitic coal. So the anthracitic coal is having a high amount of that we call it as a British thermal unit, that is the amount of heat the coal can be produced. Okay, so these are about the coal. Is also considered as a sedimentary rock because the process of formation of this coal is by the process of deposition, compaction, and all. Okay, even if it is considered of composed of organic material, it is again a sedimentary rock.